The WTO host environment will be the primary tool within all your OPS-MVS rules and OPS-REXX programs when the logic requires generating a system message. This includes single-line messages, multi-line messages, as well as WTOR messages if an interactive application needs to probe for a specific manual reply. Various keywords or operands to the host environment can be specified to control the destination, allowing you to direct the message to a particular console or consoles, syslog, or the ops log. Optionally, keywords can be added to control if the message is to be highlighted or set to a system-specific descriptor code, causing it to be set to the assigned system color. Like most OPS-REXX host environments, the WTO host environment can be routed to a remote OPS-MVS system via the multi-system facility component if it is configured. With the exception of generating a system WTOR, all tools of the WTO host environment can be used within both OPS-MVS rules and OPS-REXX programs. System WTORs can only be generated from within an OPS-REXX program running in an ops server or within batch. Let's take a look at the standard syntax for the OPS-REXX WTO host environment. Just as in TSO-REXX, the address statement is used to change or set the destination of commands, in this case WTO. The command string enclosed within double quotes will contain valid keywords used to construct the desired system message. Some of the common WTO keywords are MSG-ID or message ID. This of course defines the message ID that is to be assigned to the system message. Text keyword used to create a single line message to the system and defines the actual message text. The text var keyword will be used to generate MLWTO messages. The data lines of the message, as you will see, will be defined in stemmed variables. The con name keyword is the primary destination keyword that would direct the message that is being created to a specific console. The route keyword allows you to set the destination of the message based on route codes assigned to specific consoles. Descriptor code of the message can be set to control how the message appears on the console, such as a descriptor code of 1 to cause a red message to be created. System descriptor codes are controlled via the ZOS MPF component. The MCS flags keyword directs the message based on internal MCS flags, such as hard copy, to direct the message to the syslog only. The reply keyword allows you to generate a system WTOR and capture the reply that was entered within the running program's external data queue. WTORs can only be generated from an OPS-REXX program running in an OPSOSF server or in batch. The option keyword allows you to control internal OPS-MVS routing and processing, such as an option B to send the message to the ops log only, or an option C to cause this new message not to be subject to OPS-MVS message rules. The WTOID keyword requests that the internal system assigned WTOID be obtained and its value stored in the assigned variable name. This keyword is used to effectively DOM or lowlight the message if warranted within the application. We will have some samples here following this slide to show you exactly how that keyword is used. The system keyword is used to direct the message to a remote OPS-MVS system connected via the MSF component. This sample code is illustrating the most basic form of an Address WTO command used to create a single line message. Note the user-defined variable created that contains the value of the message that is being issued. This approach keeps the Address WTO code clean and simple, especially if the text message would expand the WTO command string across multiple lines. The REXX address statement is used to define the WTO host environment or command, and then the command string is created with the needed WTO keywords. In this example, the MSG-ID keyword is used and defines the message ID of OPSALERT to the message. The text keyword is being used to define the substituted message text, and the route keyword is used to set the internal route code of 1 to the message so that it arrives on all system consoles that are set to receive route code 1 messages. Note the output of this code as it appears in the ops log. To generate a true MLWTO within your Ops MVS automation, first create a stem variable for each of the desired data lines. In this example, a stem variable called line is used to create the data lines. Line.1 is the first line of the message, line.2 is the second, and line.3 is the third. You are currently limited up to 255 data lines. This variable stem name of line is used within the text var WTO keyword as noted in the WTO command string. In addition to this text var keyword used in this example, the message ID is used to assign a message ID of OPSALERT, and the con name keyword is being used to route this MLWTO to a specific console, in this case a console named MAST CA31, which is a valid console within this system. Note the sample MLWTO generated by this code as it would appear in the ops log. Generating alert or informational messages to a system's local master console is common logic performed in many automated applications. Designing your logic to create a common or standard MLWTO banner-style alert like these shown will allow you to implement this type of alert automation more effectively than just sending out single-line alert messages. The next 4 slides will demonstrate the logic needed to create this type of flower box banner alert automation within your applications. The code needed to generate these banner messages will be shown, as well as the logic needed to DOM a previous issuance of the alert if one was generated. DOMing a previously sent alert is of course needed to avoid backing up a console with duplicate alerts. Let's take a look at step 1 of this type of alert automation. The first coding step needed in your automated logic is to define the contents of the message that is to appear in the MLWTO data lines and will be surrounded by the flower box. In this code, the data lines, or the primary message lines of the alert, are being set to variables MSG1, the first data line, MSG2, the second line, MSG3, the third line. Of course, more or less variables can be used to address different sizes and types of alert messages. Using these defined data lines, the next step is to construct the stem variables that will be used in the complete MLWTO contents. Note the stem variable of MLW txt.1. Consider this to be the title line of the alert, and it should adhere to some type of defined alert classification. In this case, the alert being generated is for outstanding tape mounts, so the text of System Device Management will be used. Note the second and sixth stem variables are creating this surrounding flower box on the alert. And then within the remaining stem variables that contain the data lines that were previously defined, the center REXX function is used to center the contents of the data, bookended by asterisks to complete the flower box presentation. Again, the number of stem variables used for the message will be dependent on the number of data lines that are to be generated for your alert. If the alert message can possibly be issued multiple times within some short time period, including DOM logic prior to issuing the message should be included. DOM logic will of course instruct the system to internally DOM or low light a previous duplicate alert to avoid console backlog. In this code, the required alert DOM ID variable that contains the WTOID of the previous issued alert was saved within a unique OPSMVS global variable. The name of this variable will vary from the type of alert that is being generated. In this case, the drive ID is being constructed within the variable name to create uniqueness for each tape mount alert. If the variable exists as checked with the ops value function, then a previous alert was generated by this automation, and then the ops DOM function is used to instruct the system to DOM or low light that previous message. Now that the logic has constructed the ML-WTO message and DOMmed any previously issued alert, the Address WTO host environment can be called to issue the new alert message. Note the OPSINFO function being used to obtain the name of this system's local master console. This obtained value will be used within the CONNAME WTO keyword to ensure the alert gets sent to the system's local master console. The additional WTO keywords being used are MSG-ID of OPSALERT to assign the OPSALERT message ID, the text var keyword to define the name of the stem variables previously set that define the message contents, the descriptor code 2 keyword to cause the message to be highlighted, and the WTOID keyword to instruct that the assigned internal message WTOID alert is stored in the alert variable. This variable, whose value is converted via the REXX character to decimal function, will be saved in the defined alert DOM variable and will of course be used within the previously described DOM logic of this code. As in any automated application that is created, the last step is to, of course, validate the logic using the ops log. Testing DOM logic in your automation can be done by setting the browse DOM ops MVS parameter to a value of yes within ops view 4.1.1 prior to testing your ML-WTO alert. This parm will force DOM events to be logged in the ops log. From the ops log with a filter on the OPSALERT message ID that was created in the logic and a DOM message ID for the actual DOM event, you can verify the logic of this type of alert banner automation. Note the first OPSALERT banner message that was generated at 11:30:10. The WTOID assigned to this message is then used in the subsequent DOM event that occurred at 11:35:10. This DOM event, of course, occurred from the ops DOM logic that was illustrated in the previous code. Thus, the first message would have been DOMmed or low-lighted on the receiving master console. The logic then reissued a new OPSALERT banner message at 11:35:10 for this same problem tape drive. The browse DOM parm can then be set back to no after validating the logic to avoid unnecessary WTOID messages being sent to the ops log. Familiarize yourself with utilizing the Address WTO host environment by executing a test OpsREXX program in your TSO foreground. To do this, create a member in your OpsMVS user.rex library similar to this sample that invokes any valid Address WTO host environment command. Quickly execute this code as an OpsREXX program by entering and typing !OI on the command line to invoke the OpsREXX edit macro, and then validate the code from within the ops log. Many sample OpsMVS AOF rules and OpsMVS OpsREXX programs exist that demonstrate various Address WTO host environment coding examples. These samples can be used as a syntax template that of course can be copied as you create your OpsMVS automation and the logic warrants generating some type of system message. Locate your installation's CCLX rules and CCLX SAMP OpsMVS datasets to access these specific members. Thank you for viewing this video. For more detailed information about the OpsMVS WTO host environment and the complete OpsMVS product, click the information bubble in the top right corner to load the product page. From there, you can go to the product documentation, visit the CA communities, or see the learning path.